always try first.
X out.
GCF, what comes out of both?
X.
X.
Minus 7.
X.
X is 1.
7 equals 0.
0.
Right, just take an X out. Is everybody cool with that?
X is
Just
0.
GCF.
X equals 0, X equals 7.
So either this equals 0, or
Or X is 7.
X minus 7 equals 0. So X, if X is 0, obviously 0 squared minus 7 times 0, that's 0, right? If X is 7, I get 7 squared 49 minus 7 times 7, 49. 49 minus 49 is 0. So you can check it like any equation, of course, right? So the idea with this, what's the trigger that tells you when to do something freaky? We never had to do this for an equation before. It's because we never had higher powers on our X. The minute you get higher powers on your X, it sounds like I'm getting religious, but I'm not. The minute you get higher powers on the X, it's trying to tell you I got to factor this bad boy, so I get first powers if I can solve.
Like, let's say, okay, you have a higher power. Let's say, can you do the same problem if X is cubed? Like what you just did?
Sure.
You'll have 3 answers.
Could be. Up to 3 answers, yeah.
So the higher the power, the more answers you'll have, basically.
The more answers are possible.
Okay.
Okay.
All right, let's try this one here.
So an infinite number.
I think this is one like I did last time.
I don't think you did this one day. No, you didn't.
Like it.
Can we move stuff around?
You
That's an
have to,
equation.
right? All right, now, I want to step through, what is it about the problem that tells you what to do?
Form.
Take up the greatest common denominator.
You don't have a 0. You have to add 5x to have a 0.
No, no, no. What tells you to do that is the X has a cube and a square. There are higher powers on my variable that tells me to make it equal to 0.
Yeah.
Move everything onto one side.
So you're going to add 5x.
So if I
Plus
add the 5x, yeah.
Is equal 0.
So I get x cubed minus 6x squared plus 5x equals 0.
Oh, okay.
Right. So again, the big thing about that students hate is, okay, I kind of understand how to do this, but I don't know when to do this.
X.
Well, there you go. You do it when you can't get x by itself, when there are higher powers on your x.
Now you can do GCF.
X.
Yeah, good. First thing is GCF.
X.
X comes out.
X2 minus
X squared.
Now how do you factor this guy?
X is, yeah.
X and X.
The only way to do 5 is 5 and 1, right? And they both have to be what? To go
Six.
in?
Minus.
Right.
You guys with me?
Yep.
So again, I first did GCF as always, if I can. So next came out. I was left with the 3 term here that had a 1 out front. Yay! So all I need is the 2 numbers that multiply this, add to be this. 5 and 1, they both have to be negative to come out negative 6.
So X equals.
Now I'm done factoring, I can get my answers. Either x equals, either this equals 0,
Or X
or this equals 0,
X5.
or this equals 0. I really want you guys to understand that step. That step is kind of stupid. Really. It's kind of like, well, duh. If I have 3 numbers multiplied by 0, that first one's got to be 0, or the second one, or the third one. One of them's got to be 0.
So x can equal 0,
X can equal 0.
5, or an x can equal 1.
X can equal 5,
X1.
or x can equal 11.
Sometimes.
Some of you guys might remember this, and you can kind of just look at this and tell it's going to be 5. What makes that 0? 5. What makes that 0? 1. Yeah.
Sometimes at the end, one of them has no solution, so we have to leave it.
The no solution comes out of a word problem. So in this example, it doesn't really work. I mean, if I would have gotten a negative answer and I got a word problem that says I want to build a fence, you know, around something and get negative 7, I hope to God you would throw it out. Right? The math is okay with negative numbers. The physical reality, I'm not sure how to make a negative 7-foot long fence. Right? I don't know. Black holes.
Black hole.
Buckaroo Banzai, 8th Dimension. You guys ever seen that movie? Look it up.
Looney Tunes would probably do it for that.
Young's missing out on so much cool stuff. All right.
What's the name of that movie?
Buckaroo Banzai. In the 8th Dimension, I think. It's in the Adventures of Buckaroo Banzai in the 8th Dimension.
I used to love watching that.
The title is entertaining shit. All right.
Jeff, how do you know I used to love watching?
Last one here. I want to show you one that's well, let me see if you guys are cool. Let's see if you guys pick up on something here.
That's an equation, that's good.
do the brackets first, right? Do the parentheses first.
Distribute.
No, you subtract 4x plus 2.
No,
no.
distribute.
Now,
Distribute first.
look at this. Are there any higher powers on my x?
No.
It's just the first power. So this is a chapter 2 problem. What I want you to be careful, anytime I teach you guys something new, you kind of want to apply it to everything. This doesn't change. This is old news. Yeah, so you bring the 5 in,
X plus 1x.
and you bring the 2 in.
Yeah, 4x plus 6.
6 minus 2x.
Get your like terms together,
Yeah.
right? This is, I just want to make sure that you guys don't make a mistake of trying to apply the wrong procedure at the wrong time. What told me here that it's going to be an easy problem? All the x's are to the first power.
Yeah.
What over there is going to be slightly harder. There are some x's to higher powers. That's what tells me to set it equal to 0. Do I want to set this one equal to 0? No. I want to get my x's on one side because I can, and my numbers on the other side.
Yeah.
Over here, I can't put these x's together, can I? They're not like terms. I got to have another way to do it there.
Only
Here.
one answer.
Subtract the 2x,
Yeah.
Add your 5.
4x.
add the 5,
So you have 4x equals 11.
5 by 4. Ugly answer, I don't care, I'm done.
No need to say it's equals 0.
Did we have to do that before? No. So I don't have to do it now either. Every time I teach you guys something new, for example, somebody likes to tell me this. Why would somebody think this is true? Because of what we learned. We learned that a negative power means flip,
It
right?
has to go.
Then all of a sudden people think, well, every negative flips.
No.
I wish. I owe you $5. Well, no, actually, you owe me 1/5 of $1. Ah. I can't make a negative become positive, can I? A negative power means flip. Negatives never meant flip, and that doesn't change. Properties never change. We just learn new properties for more advanced problems. This problem doesn't change at all from what it was, because it's still the same problem, right? What tells me I have a kind of a new problem, something new to us, is when I have an x that has a higher power than 1.
Mm-hmm.
Then I knew to attack it in a new way. Do you guys see? This happens a lot of times with math students. You learn something new and you start applying it to old shit, and it gets all confused. No, do the old shit the old way. So here we go. What about this? Watch this. This is probably the worst you would see in this section. I guess this should make it work. That would be nice, Jeff. Would that be nice?
Yeah.
Yeah, okay, that'll work. Yeah. This is the way the problem is given to you.
Okay.
So if I look at it in this way, like somebody did work up to here, what did they do wrong?
They didn't get 0.
0.
Yeah, they factored before they got 0 on that side. So I have to kind of undo some of their work. We're like, it dorks. So like, I think, you said, man, you gotta FOIL it out. So unfactor it. Minus 4x plus 5x is x. Is that cool if I save a little time there?
Yeah.
Equals 22. So you
Add.
multiply it out, you suck the 22 over,
Yeah.
and then you factor it at the right time, right? So some of these problems are going to feel like you're going backwards. It's just because part of it's factored too early.
So your next step is to add 22.
Yep. Well,
Minus.
Minus
subtract 22.
So you have x squared minus x minus 20, or minus 42, sorry.
Now I can factor because it's equal to 0.
Yeah.
That's the key. It's got to be equal to 0. What I always get here, though, is somebody tells me, well, x minus 4 equals 22, or x plus 5 equals 22.
6 times 7.
That doesn't make any damn sense, does it? Why would one of them have to be 22 to multiply to 22? It could be 2 and 11,
6 and 7.
right? It could be 44 and 1/2, who knows? Do you guys see what I'm saying? You gotta have a 0 on that side for this method to work. Because otherwise I don't narrow it down to one possible thing. Something's gotta be 0. So yeah, like you're saying, it's gotta be 6 and 7. Which one's positive?
7.
The 7.
But that doesn't matter which one's positive and which one's negative.
Of course it does.
Okay.
Because they gotta get a plus x in the middle, right? Bigger dude's gotta be
Means 1.
positive. So
Bigger
x
dude.
equals 6,
Because the little dude's going to
or
cancel.
x equals.
Negative 7.
You guys see that?
Yeah.
If you don't like that, you can set up the equations, right? And then just solve. You'll still get 6, and you'll still get negative 7.
Because the little dude's going to cancel, right? That's why.
What's the difference between this and this?
What is the difference between this and this?
Yeah, because
Why did we treat them differently?
Because
That was set up wrong to begin with, in the top.
What's the highest power on the x here?
Square.
Square. So there's a higher power than 1 on my x that tells me what I
That is
have
right.
to do. Why can't I do this problem the same way we did this problem? Can you get all your x's together?
No,
No, I can't combine those.
because they're difference of power.
That's the difference. Whenever you have a higher power than 1 on a variable, you know to get it equal to 0 and factor. Why? Because we can't do it the old way. The old way involved getting all my x's together, didn't it? I can't do that over here. I can't get those together. Shit, I need a new way to do it then.
Does it have something to do with the absolute value?
No,
No.
no.
No, no.
Okay,
Maybe.
so that's my review of 5A.
5-9.
Now we get into new stuff.
5-9 or chapter 6-1.
6-1. No 5.
We're on 6 now?
Oh, yes.
What the hell's going on?
Oh, functions, wonderful.
Now, I think I said this last time, but the better you are with factoring, the easier chapter 6 will be. If you're really good with factoring, chapter 6 will be easy.
easy.
Because that's all it really is. Factoring is the hardest step in chapter 6. If you got it down, you're good. If you suck at factoring, don't try 6 yet. Get factoring down, right? What section 6.1 is all about is called rational expressions. And what kind of a number is a rational number?
It's like a fraction, right?
Ratio of things, right? It's fractions. So rational expressions, I can see some of the guys are like, rational expressions are fractions that have variables in them, right?
A over B or stuff like that.
Something like that. So for example, let's go back in time for a second. How do I do 18 over what, Jeff? Over 15?
You're gonna find a GCF, which is 3.
18 is 3 times 6. 15 is,
3 times 5.
so the common factors
6
cancel.
over 5.
6 over 5.
Why exactly? Because division is the opposite of
Multiplication.
multiplication. Cool? So why can't I reduce 9/8? Can you reduce that?
No.
No. There's
That
no,
won't reduce, right?
there's no
Don't tell me
GCF.
it's a mixed number. Reduce it. Will it reduce?
No.
No.
Even though 9 is 3 plus 6 and 8 is 3 plus 5,
You can't
I
do
don't
that.
care. Do those 3's go away?
No.
Because division is not the opposite of addition.
No.
But you won't believe how easy it will be for you to do this. When I start making variables in there, you just say, oh, there's 2 x's, kill them, yay. No. You can't break into an addition problem with the division. It can't do that. So an example just like this with variables would be this here. Let's say, what now, Jeff? Let's do that.
X plus 3, X minus 3. Never mind.
Now, some of you guys are like, how's that just like that? Same idea. I have a number up top and a number on the bottom. What did we do here that I normally don't write? But this is what you do in your head, isn't it? You say there's a 3 in both and I kill the 3.
It's gonna factor the 2.
X minus 3, X plus 4.
So please, dear God,
You just find a GCF.
do not
and then-
do this.
No, because they're a unit.
Right,
They're
you
like
gotta-
together, yeah.
Because division does not cancel subtraction.
Okay.
But how does the top factor?
X minus 3, X plus
X
4.
plus 3, X minus 3.
Right? Isn't the top a thank God problem, a difference of squares?
Yeah.
And how's the bottom factor?
X.
3.
Okay.
4 and
3 and
3.
4.
6 and, no, that's right. That's
Okay,
half.
minus 4 and plus 3.
Careful.
Oh,
The
wait,
bigger
minus
one's
one.
gotta be plus.
Plus 4 minus
I was
3.
thinking about-
Now, what cancels?
Cancel the X 3.
I love it. You guys are so